Oh, you guys are doing all that here. I'm just filming it. Okay, don't.
Yes. It's time to begin the lightning talk session. So this is the final session for today. So there are all of lightning talk speakers here. Yes. And yeah. So I believe so everyone knows so that there is no question time for the lightning talk session, and each speaker only has up to 10 minutes for their talk. So the first lightning talk speaker is Mr. Andy. Please come to the stage.
Oh, I think this is the old version of my presentation slide. No. This is the old version. I upload the newest one yesterday.
This is older.
Yeah, this is the old version. Maybe I can return to the speaker so I can prepare and give them.
You said this is older one. So that can you?
Okay, we'll check.
There's a new one. Okay, so instead of Mr. Andy, so Mr. Sajao is here. Please come to the stage.
Good afternoon, everyone. My name is Sajidur Rahman Rabbi. I'm a Network and Security Administrator from Bangladesh and a EPNIC 60 Fellow. Today, I want to share with you guys what it feels like to watch your entire country vanish from the internet. Is this what? So it was July 2024. I was in the Meghalayan mountains in India, having a peaceful vacation with my wife. And I suddenly noticed that none of my WhatsApp messages to my family was going through. No one in Bangladesh was receiving my calls. None of my bank cards that I had with me were working. Everything was okay from the India side, but back home in Bangladesh, things were unraveling. Mass protests had erupted across the country and has escalated to levels never before seen. And in sheer desperation, and in the last-ditch attempt to de-escalate the protests, the government decided to cut the internet nationwide. Not just social media, not just mobile data, everything. From where I stood, connected online, I watched in real time as my country, Bangladesh, fell off the internet map. Even to return back to my country, airlines couldn't verify my tickets because there was no API response from the local airlines, the local airlines websites where the tickets were hosted. And no news, no information at all was getting in or out of the country. Inside Bangladesh, people were completely cut off, and outside, people were helpless. So this wasn't a natural disaster you prepare for. It wasn't an infrastructure breakdown. It wasn't even a DDoS attack. It was a completely intentional, calculated political move to silence dissent by shutting down the internet. But in doing so, they didn't just mute the voices. By shutting down the internet, they froze the entire country. All foreign remittance of the country, the influx that comes from outside, came down to zero, as all remittance sites are on the internet, causing massive financial damage. And there was no backup. VSAT or satellite internet was never allowed in the country. Starlink banned until after the blackout. No alternative connectivity, no regulatory independence, no way out. This went for 11 days. And that's how I realized the hard way that we take so many things in life for granted, especially the internet. In 2025, the internet is just not entertainment. It's finance, it's transportation, it's communication, crisis response, freedom, and dignity. In APNIC 60, during our workshop or even in the conference throughout the week, a lot of the presentations talked about the question, who owns the internet? And the diplomatic answer that has been given to us all the time is no one. The internet belongs to everyone, right? Yeah, I'm not so sure. At least it didn't feel like that to the Bangladeshi people during the July protests in 2024. So I think I found out the answer as to who owns the internet. It's the people who have the power to kill it off. At least that's what I felt like during this whole ordeal. This raises a terrifying question. How did we let this happen? Should any government have the power to shut off the internet for an entire population? When one central authority controls all the routing, all gateways, all ISPs, this is what happens. And it happened in Bangladesh. It can happen anywhere unless we learn from it. We need to talk about multi-stakeholder internet governance, independent regulatory bodies, and connectivity resilience. The blackout is over now. After the decoupling of the old regime, the first thing the interim government has done is authorize Starlink. So Bangladesh now has an alternative form of accessing the internet. People are now talking about regulatory reforms, but it's a shame that this all came after the damage was done. The lesson is simple and urgent. No political party, no government should ever have the power to silence the nation by killing its connection to the world. We need redundancy and we need policy safeguards. And we need to treat the internet as what it truly is, a basic human rights. Thank you.
Thank you very much. Thank you. So Andy's slide is well prepared. Okay. The second lightning talk speaker will be Andy. Sorry, Andy.
Okay.
You will be the second or third or fourth speakers. Sorry. Let me try again. And yeah, the next speaker will be Mr. Ariev. Please go to the stage.
Okay, good evening, everyone. My name is Alif Fauzan. You can call me Alif or Al for short. I'm a student, a youth fellows for the Ethnic Fellowship. This is my first time here, but I've been pretty active in the internet community before. I'm from EPI community, or if you guys haven't know, it's under the Soy Asia, and it really opened a lot of opportunities for me. I learned a lot there. I've been a teaching assistant for 2 years now, and then I finally got my Ethnic Fellowship. I've been applying for the New Zealand fellowship, but sadly I didn't get accepted. And that's why my father always said, go big or go home. So I try to spoke my thoughts here. The problem with a youth, especially like for the university student, we don't know about any of the internet community. We have Epinic, we have ICANN, ISOC, EPI, or any other community which has their own event, fellowships, and others. But if you haven't got exposed about that, you won't know. And that's the problem because internet is for everyone. I think you all agree, right? And that's also the goal. Like for most of the communities, they have the youth fellowships because they want to introduce our community that has been established to the youth, especially as much younger as they can, so they can be actively participating and actively contributing. And my main point is even though internet should be decentralized, it should be distributed everywhere, the community itself doesn't distribute well. Next. Sorry. How is it? Okay, so the headache of applying to any internet community is it was really decentralized for information that should be centralized. For every community, for every event, for every fellowship and others, you need to check their own web. And if you don't know what are their community, what are they doing, you will read a lot of that, and then you will miss all the deadlines. And after that, you will try to apply for another community, but then you miss all the deadlines again. And it will be like a very huge spiral, especially because right now we are Gen Z. We don't have very much attention span. We can't take a look of something more than 10 minutes or 5 minutes even. And when we are getting confused with the information, we will skip. And that will be a loss for the fellows, youth fellows, and for the community itself. Okay. Oh, this one. Okay, so this is my past experience. I've been like searching for many communities before, and even like any other scholarship, and I'm getting confused. I'm getting lost in the sea of informations, and I miss the deadlines. So that was the solution that I proposed. It's a net agenda, your one-stop event reminder. What is a net agenda? It will help for all the agenda of the network community and all they can offer, which is a decentralized information for everyone. We contain everything you need. We will get the information for all the community, for the ICANN, ISOC, Epinic, EPI, for all the inter-communities. We will have the application there, so you don't need to go to separate website for every other applications, and you won't need to make an account for every other community. And the problem with students, they will know the applications, but they are deadliners, right? They will miss the deadlines. That's why we will give you the reminder for all the applications. And who is this for exactly? For the applicants. It can be students, it can be youth, professionals, and anyone looking for the events. And for the organizer. For me, myself, I'm coming from the EPI, and now I'm an Epinic Fellows. And I think most of the internet community want their information to be scattered around, where they want everyone to know their community and they can participate and enjoy. Why? As I've said before, we don't want to lose in the sea of information. And with next agenda, you can apply, you won't lose the deadlines, and you will know the notice when you got accepted, or you can apply for another if you haven't. And then it will help you to the conference. So I hope this solution can be proposed, especially for youth fellows, and with targeting a university and more youth people, because I don't think there is a restriction age for student, and I hope like everyone can participate in the internet community. Thank you very much. That's all from me.
Thank you, great lightning talk. So, Mr. Andy, can be the next? Okay. Andy. It's your time.
Okay. Okay.
Finally.
Hello, good evening, everyone. My name is Andi Paratambunan. I'm from Swiss German University, Indonesia. Today, I will present my talk title that detecting the true nature web attacker. This is the bot, human, or automation tools. So this presentation focus on understanding of the web attack unfold. So basically, why we identifying their nature is critical in today's cybersecurity landscape. So this is brief introduction about myself. I am one of the student of master degree, graduated soon, and work interest is talking about the threat hunting, threat intelligence, and attacker behavior analysis. So based on the data from the Shodan, we can look more than 233 millions data internet services detected. Nearly 59% of them is detected as a web service. So the dominance highlight why web services are so important. Almost very modern digital interaction, such as like application, API, and cloud platform is realized on them. So this is the reason why this research focus on web service. So we can analyzing activity here. So we can undiscover the real of the attacker behavior in HTTP service. As a background, web attacks today are mostly conducted by bots, automation tools, or human attacker with varying level of manual control. But several previous research is just focusing labeling bot and non-bot. That know between the two category. The previous research is not talking about the automation tools, but as a attacker, I know I use the automation tools. And the second, most existing analysis is only payload-based analysis and stateless, ignoring session behavior. The previous research is only mapping the attacker behavior is only fragmented requests, just only mapping to their attacker behavior or activity just one by one. But the attacker is only using the attack session, not its activity. So we need to look the attack session base to undiscover the attacker behavior. Treating all attacker the same leads to encourage assumption and ineffective defense. And identifying who the attacker really is a bot, tools driven, human, or only manual actor can dramatically improve deception and defense strategies. Based on that gap, this research has several objectives. The first is to use HTTP honeypot logs and we extract the real behavior pattern from actual attacker session. And second, to apply a session-based perspective to obtain in a holistic view instead of analyzing requests in isolation. And the last one is to generate insight that can help us improve honeypot realism and develop more adaptive cyber defense mechanism. Okay, this is my research flow. So I put the HTTP honeypot so the adversaries can interact with my HTTP honeypot, that I will capture the all activity of the attacker. So I can analyze the attacker behavior. I using multi-stage analyzing using supervised learning and unsupervised learning. The first, I using the random forest in supervised learning and XGBoost learning to separate bot attacker and non-bot attacker. After that, I using the, sorry. Okay, the second stage, I using the unsupervised learning that non-bot attacker that labeled before in the stage 1, I using the key means, the key equal to apply behavior features using several features like user agent length or entropy, header count or diversity, URI diversity, and timing pattern. So the output is 2 cluster. The cluster 0 is I identify as automation tools, have behavior low user agent entropy, repetitive signatures like that I collect is mostly using the Mozilla /5.0. And the last one behavior is regular request interval, mostly get method. And the cluster 1 is human attackers that have varied and mixed user agent using the tools user agent or the real browser. And the second behavior is irregular timing pattern. And the last, more diverse HTTP methods such as get methods, post method, and another uncommon verbs. So this is behavior key findings that I get. The behavior of the bots is this deterministic pattern dominated by Mozilla user agent, mostly get requests, payload often empty. And automation tools is mimic browser signatures, maybe like the bots, but have a highly repetitive pattern because many automation tools is just for the scanning vulnerability or dictionary. And the last is predominantly get requests. And the last category is human attackers, is more diverse method and mixed user agent. And the last one, higher entropy and irregular behavior. This is a quantitative result from our research. We put some picture that show you the key behavior indicator across attacker classes. So quantitatively, we can have some conclusion that multi-stage framework effectively separate web attacker, not only bot and non-bot, but we have the precious 3 category is bots, automation tools, and human attackers. And the second, refined taxonomy provides deeper insight to for threat detection, profiling, and attribution. And the last one is automation tools stand as their own class, bridging the gap between pure automation and human behavior, no longer hidden inside the broad non-bot category. Okay, that's all from me. Thank you so much.
Thank you for a great lightning talk. And next speaker will be Miss Fatima. Oh,
Okay. I am Thies from RIPE NCC. I work on RIS and RIPEStat. And today I want to show you some ways that you can use the BGP data that we have at the RIPE NCC. And I'll show 3 easy ways to do it and 1 harder one and one that is extremely cool, I think, but is difficult. But I still want to show it. Okay, so RIPEStat is an information service from RIPE NCC that offers information on IP addresses, autonomous systems, a bit on host names and countries, and mostly does that through visualizations. And you may know it. To do this, we use a lot of various data sets. Some are open, some are hard to get access to. For example, we get data from the RIPE database, so that's our name for what WHOIS is. From the routing registries, so the RIPE NCC IRR, but also APNIC and all the other ones worldwide, the authoritative ones and the other ones, DNS data, and we have a lot of BGP data that we gathered over time, and that's what I want to talk about today. What we do is we run a network of route collectors worldwide. We have 23 collectors active in various locations worldwide. And we have BGP sessions either over the IXP where the collector is, or over the internet. We call it a multi-hop session. We get a BGP message from all our peers, shove those into a Kafka message queue, and from there we generate a bunch of data products. So something called MRT update files, MRT bview or RIP files, where we create the BGP state from the messages. We have a looking glass that's real time from Kafka. And we have a lot of internal data products for RIPEStat. And we have a special one for RIS Live. And now I want to show the 3 easy ones and the 1 harder one, and then something that's very cool for me, but also quite difficult, but I just like it, so I want to talk about it. So the first one is real-time data in RIPEStat. You guys all know general looking glasses. You probably also know BGP Tools has one that's maybe even better than this. But we have a real-time looking glass over all the RIS pairs where you can filter in the AS path. So you can quickly say, okay, if I have this, the prefix from KRoot, the DNS root server that RIPE NCC runs, and we have this specific upstream provider that's hosting it, where does it propagate? How visible is it in BGP? Another data set that we have that's unique, and it's probably because it's very annoying to store because it gets big, is the history of all the prefixes that we've seen on the internet since the beginning of this route collector project. So basically, for every prefix that we have seen, we can show when it was visible on the internet, and also the less specifics since 2000s. So if you have a new customer that shows up and asks you for transit, and you want to know, like, hey, is it logical that this AS is announcing this prefix? This is a very good tool, because especially for legacy prefixes, sometimes the status is a bit strange. So with this tool, you can look at the behavior of the prefix and see if it's always the same AS announcing it. And we hear that it's a huge help for operators. Another tool that we have, which is slightly more in depth, is a thing we call upstream visibility. So we have around 400 full BGP tables, and we look at what AS we see at what distance from the origin. In this example, I have a prefix from a provider where somebody created an AS0 ROA, so a prefix that became RPKI invalid, And when we looked at the first upstream, you saw this drop of the same shape you see here. But then if you look at the distance too, you see the various upstream providers of this network, and you see that various upstreams started filtering, and that one of the upstreams that wasn't very big at first became one of the dominant ones that was still transiting it afterwards. And implicitly, I think you can say that if something becomes RPKI invalid, it becomes about 70%, 75% less visible on the internet. Now, the first complicated one, which I won't really show here, but it's nice if you want to look at the timeline of what's happening with the prefix, is BGPlay. We recently changed this, made it look fresher, made it work better, just like upstream visibility actually. And here you can look at how the routes for prefix changed over time. What BGP updates were there, and was it an update that replaced a current path? Did the communities change, etc.? So if something weird is happening and you select the right collector that has the data that you want, you can really see a timeline of what was happening. So if this is the same prefix I looked at the previous one, what you see here is that the situation is very stable. Then there were some updates, which is logical because BGP always changes. And at some point, there's a huge spike with a lot of messages very close together when the RPKI validation starts to change. And a lot of networks over the internet slowly start to filter the route or not. And all of this is built on the routing data from the route collector project that we collect as MRT BGP dump files. And these are actually a bit scary, I have to say, when you first hear about it. And I know that when I started on this project, for the first months, I didn't look at these actual files because they were a bit intimidating. And later on, I realized that you can actually parse these with command line tools and other stuff. So you want to see the BGP updates in a certain 5-minute window, you can just download the file, open it with Monocle from BGPKit or BGP Reader, and then you can pipe the output through grep, and you can see the updates that affect the prefix. What you can also do is write code, and I'm a software engineer, so I always think that's easy, but actually that's the part that's intimidating. And you can do some custom analysis. But what Anurag does, and I think I'm probably pronouncing your name wrong, is he puts the updates in ClickHouse as a database. And of course, we have this data in a database internally for RIS, but I wasn't aware of many people doing that on the internet. And that way you can do a lot of quite complex analysis that we cannot provide for you because it takes a lot of time to calculate. For example, I think I linked an analysis of how Tata's prefixes are being transited by other upstream providers. I wrote a short tutorial on that. That's behind that QR code. So if you want to have BGP updates in a database and query it, you can follow this tutorial. And a colleague assured me that it works, so it hopes it works for you as well. And otherwise, contact me. And we hope to present something easier for this on RIPE Labs, where we index the files for you already. So you just have to download the file and start the database. And to prove that this works, you probably have all seen SQL. And it turns out that LLMs are really, really good at SQL. So if you write this this query, you can analyze the upstreams this way, just by writing some SQL, filtering the data, and then saying, okay, give me the first upstream, give me the others, count them, or just give me all the rows. It's a really versatile way to analyze what happened. And if you want to dive deeper into these collected BGP messages, I really recommend you try it and don't be scared of it, because there's a lot of cool analysis that you can do this way. And yeah, this is my main message. I want to show you that this routing data exists. It's useful through tools. You can contribute data to this routing project. We have a selective peering policy, but we really want to get data from mostly IXPs if we can get it, because that's where the connectivity happens that you don't see further away on the internet. I showed the 3 easy ways, I showed BG Play, and I hope I did a convincing pitch that putting us in a database is not that intimidating. Thanks for your time.
Thank you for your talk. Great talk. Thank you very much. And, let me introduce next speaker. Miss Fatima is here. Instead of Fatima, you use present. Fatima is not here. Unlikely. Okay, so let me introduce another session chair, Mr. Christopher. Let me have my.
Hi, ladies and gentlemen. My name is Christopher Hawker. I'll be your MC for the remaining few lightning talks today. Our next speaker that we have is Yihao Chen, who'll be coming up to talk about leveraging open source intelligence for automated BGP incident attribution via LLM-based AI agents. Please give him a round of applause.
Hi, I'm Yihao Chen from Tsinghua University, China. And what I want to share today in this lightning talk is exactly in the headline here. I want to talk about the value of open source intelligence, or more generally, the knowledge on the internet, such as those in the Wikipedia pages. The value of them in the attribution or analysis of BGP incidents. And also, I want to talk about the potential of large language model-based AI agents in automating this analysis process. And here is a motivating example that I also presented in yesterday's talk. Basically, this is a BGP hijacking incident in the real world, where there are the supposed hijacker and also the supposed victim. They are both the networks, and overall, this incident looked very anomalous from a technical aspect, because those routes involved are RPKI invalid, and they are conflicting with the IRR records and also the WHOIS records. But when we look into some information on the internet, for example, if we search those involved networks using a search engines, and we would find those Wikipedia pages about these involved networks, for example, the supposed hijacker and the supposed victim. And we found that their parent organizations actually have a partnership. So inherently, with this information, with this general knowledge or open source intelligence, we came to the conclusion that these supposed hijackers and this is supposed victims in this case, they are basically sharing the same interests, and any services affected by this incident would likely to stay within their own scope. So that's how we came to the conclusion that the incident is denial rather than a deliberate attack. And we found the value of the general knowledge in this case. So first of all, I want to talk about why it is important to tell whether an incident is denial or malicious, because there are many denial misconfigurations in the internet, and in the meantime, the delivered attacks are relatively fewer. And knowing whether an incident is malicious or not can help us to focus more on those actually matter. And from our experience, if we report to network operators about a benign misconfiguration, they usually do not care. And if we tell them it is a deliberate attack, then they would be very concerned. So this is actually valuable to find the intent behind an incident. And we found there are some challenges in this task. For example, in the case I just shared, we have to find those hidden relationships between the involved parties, and this relationship might be multi-hopped. We have to find their parent organizations and then find the link between their parent organizations, and then piece all this information together. Can we finally come to the conclusion? So there is a reasoning process, and also such information are usually lacking in the traditional routing data. Even in the KDAS relationship data, we do not have this direct relationship records between those involved parties. We have to reason them out. And what's worse, such information is usually scattered all across the internet, across different sources. They might be in Wikipedia pages or might be in other websites, and they are usually in the unstructured text format, which require parsing and also understanding. So these are the challenges. And actually, we found the capacity of large language model might help to solve this problem. And imagine if we have a large language model based AI agent, when it was given an incident, and it can adaptively decide what kinds of sources of information it should require, and it can go and gather this information from the internet, and also synthesize all this information together along with those domain-specific data. For example, the RIPE stats or RIPE reads data just shared, and then it can reason through it to get a better report, which is human readable. So this is the proposal of using a large language model. And here is my initial thoughts on the intelligence sources that might be helpful. For example, there is the general knowledge, such as those Wikipedia pages about a network or about a company, and they have the official website telling us about their services. And also there is the business intelligence, and also those operational sources, such as the, for example, Epinic blogs or their mailing lists. There might be some useful information about specific incidents. And also there are cybersecurity websites. For example, the SpamForce, they offers a list of autonomous systems that might have a bad reputation, which can help us to identify attack. And there are also social media. Some network security analysts might post a social media post about incidents, so it can also help us to analyze something. And that's my thoughts on this issue. But there are also many questions need to be answered. For example, who actually need this kind of system? Does network operators actually need it, or do security analysts need it? And also, how to control the cost of an AI agent? We know large language models is very costly, and is it scalable enough to process a large scale of incidents? And also, do we actually need a fully automated agent, or do we actually can work better if we supervise the large language model and to have a better workflow? So these questions are not answered, and I'm just sharing with you. And if you are interested, and we can have a discussion later. Yeah, thank you very much.
Okay, so our next presenter is Rafael Sintra. Hopefully I didn't butcher his name. From APNIC presenting a talk on potential security vulnerabilities in relation to the APNIC Dash platform. Thank you.
Thanks, Christopher. Okay, good night, everyone. My name is Raf, and I work with the information products team at APNIC. And tonight I'll be talking about this new service we are introducing, we call potential security vulnerabilities in Dash. So for those not familiar with Dash, it's APNIC's network health dashboard. It's available for all APNIC members at dash.apnic.net. And it's a product that allows our members to track and get notified about routing and security issues in their network. So why Dash? APNIC conducts every 2 years survey with its membership to ask our members what are their needs. So in the last 15 years, internet security is always on the top of the list. So you can see in the survey that we conducted last year, internet security was on the top 3 strategic challenges and was the #1 operational challenge for 57% of the respondents of the survey. So Dash is one among other initiatives from APNIC to help our members to tackle internet security. So let's go quickly on the current service in Dash. So let's start with routing status. So routing status is a service that gets all the routes visible in BGP for our member and compares against RPKI and IRR. So if they have any issues, any misalignments between BGP, RPKI, and IRR, we will inform our members if they have RPKI invalidities or if there are routes in BGP that are not covered by route objects in IRR. So they can create alerts for these sorts of incidents, and they can also create alerts for problems in BGP, such as if there are potential BGP hijacks happening or if there's loss of visibility in their routes, so they can get notifications near real time. The next one is suspicious traffic. So this was the original service in Dash that is based on the APNIC Community HoneyNet project. So this is a project led by our security team that we have more than 400 honeypots around the globe, and we have all this data, and we use this data to inform our members if their networks, they are originating suspicious traffic. So maybe some of their machines could be, for example, infected with malwares, and we help them to fix these issues. The next service is Bogons. So we use this service to also inform our members if they are originating or propagating Bogons. So this could be due to misconfiguration or perhaps lack of filtering. And finally, we have the Manners Readiness Score that basically tells our members how compliant they are with internet security best practices. And we give them information how they can join Manners program to implement these best practices in their network. And today, we will be talking about potential security vulnerabilities. That is the new service that we are implementing as beta. Okay, so this new service, we are using a third-party security service called Shodan that was actually mentioned earlier today. And Shodan basically scans the whole internet every week, and they have this massive database that we can query for vulnerabilities in different networks. So we use this service to inform our members about vulnerabilities found on their network. We have a vulnerability list that is created by APNIC security and network experts. You might be familiar with Adley, Shane, and Dave. So they will be creating these lists. And for example, one example of vulnerability could be an open service can be exploited to amplify DDoS attacks. So this is an example of when you click on one of the vulnerabilities. So we present the complete list of the hosts that were found in your network with that vulnerability. So we provide information such as the IP of the host name, the ports, and when the vulnerability was last detected. We allow you to dismiss that vulnerability, that entry, if you think it's not a problem, for example, or you can also completely dismiss the whole category if you are not interested in that vulnerability category. We also allow users to filter resources either by ASN or prefix. So maybe you have you are only interested in a subset of your prefix or specific ISNs, and the other ones it's not perhaps managed by you, so you're not interested. So we allow you to let us know exactly what are the resources that you are interested to check vulnerabilities. So this is a beta release. We just released last weekend. The final version will be released in the next couple of weeks. The real missing feature right now in the beta release is missing the ability of downloading full reports. So if you go to a vulnerability, you can only see the first 1,000 hosts in that vulnerability. But this will be addressed in the next couple of weeks. And finally, your feedback is very much appreciated. So please try the new feature and please talk to us. We would love to hear from you. If you have any comments, questions, and please let us know how we can make the feature more valuable. And that's all I have. Thank you very much for your time.
Okay, now our next speaker is Fatima De Silva Caldas with their talk on solar-powered ICT labs. Do we have Fatima in the room? Okay. All right, bear with me just one moment. Okay, our next speaker will be Shishio-san from Arista with their talk on BGP malformed update and attribute lists.
Okay. Thank you for introduction. My name is Shishio Tsuchira, Alice Network. I'd like to explain the BGP malformed update and attribute list. This presentation is a summary over the Nanog mailing list. We see the Nanog mailing list on this year, the May 20th. The someone posted, did anyone BGP flop 701 UTC? And our BGP session flopped. Another ISP sold the same thing. And discuss over subscribers behavior of each vendor when the BGP malformed update received from Nanog mailing list. The vendor is Juniper, Junos, and Cisco IOS XR, and our Arista EOS. This is the Juniper. Juniper use, some people use Juniper but kept BGP session because enable the BGP error tolerance. It is default since Junos OS release 24.2 R1. But they send malformed attribute of a prefix set, attribute number is 40. And some people, maybe Randy Bush posted, seeing this error message. Maybe this is the iOS XR. It is a show BGP update error. Also send attribute 40, which is a prefix set. And this is Arista. Unfortunately, the BGP session reset on the 7280 are 4.297. Unfortunately, we have a bug. Malformed prefix set BGP plus attribute will reset in the session rather than the attribute discard. And some people wrap up this topic on the blog, and this slide is wrap up from topic to my slide. BGP update for the /60, it has BGP prefix sheet corrupt with all over internal data beginning 0 Junos didn't session reset, but it sent to the downstream. Arista EOS has bug, and the BGP session reset, it not running. If it is not running a fixed version. iOS and Nokia SROS implemented RFC 7606, revised error handling BGP on the attribute discard, which is defined and the prefix in the defined on the RFC 8669. It describes on the how to error handling if malformed update, if received malformed update. And this is summary. Malformed BGP prefix update was seen on the May 26th this year, and bug does not support BGP sheet. The message was distributed to many multi-terabit internet exchange without being filtered. Cisco iOS XR and Nokia XR OS discard the attribute regarding to the RFC 7606 attribute discard. It means RFC 8669 behavior. Juniper kept the BGP session, but it updated to the downstream. Arista EOS has bug, BGP session was reset. But it is a bug for this specific attribute. Implement RFC 7606 as a default. This is summary RFC 76 device error handling BGP update message. And there is several behavior. Session reset, treat as withdraw, AFI, sub-AFI, disable, attribute discard. And this is our implementation. EOS already implemented RFC 7606, and the handling invalid update receives also displayed via show command like iOS XR and the Junos. And this is ignore BGP attribute. In the EOS, you can specify the attribute received via AFI for specific neighbor. This might one of workaround solution of the operator who cannot use the latest image. My presentation ended. Thank you for your attention.
Okay, look, I think we may have time for one more talk. From what I've been told, it's from one of our current fellows. Just trying to, sorry, do we have Shane in the room? Oh, sorry, Shane from the Secretariat. Ah, there she is. Sorry, bear with me, please, one moment. Okay, sorry, my apologies. I'm afraid we actually don't have time for any further presentations as it's now 7 PM. Okay, out in the front foyer, we now have the Meet the EC social, where you will have the opportunity to meet the EC, interact, socialise, have a chat to them and get an understanding of the work that they do with APNIC. So look, I'd like to thank all of our presenters this evening, and we look forward to speaking to you again soon. Thank you very much.
People are nice, but it's only for the tips. The weather's fine, but it's nothing I will miss. My only friends are the ones I left behind. Wish I could see them just for a moment. 'Cause I don't know anybody here, it's awfully lonely. I smile, but they just stare. And I see misery everywhere, it's getting to me. I cry, but they don't